Hey y'all, Venture Brad here, and this is my little electromechanical motor. Solenoid, piston, rod, crank, flywheel, there's a bearing down in here, timing device, power source, fuse, watt meter, power source. So anyway, what is all this? Well, first I want to take a pause right here. If you're a super powered user, obviously this is a reciprocating motor. Which way does it spin? I want you guys to take a guess right now. Does it spin clockwise? Does it spin counterclockwise? Which way does this motor run? So anyway, let's get into how, and back to the real subject here, how this motor was engineered. I guess we'll just simply take it off the crank here. Let's talk to you guys a little bit about how this motor, my thought process, how I came apart the dimensions, so maybe you guys could design your own. So pretty much this started around this salvage solenoid that came out of a RV window rolling up and down motor shade, and this was the lock for the gear drive. So when you went to move the gear drive, it enjoys the solenoid, pulled the solenoid away from the gear drive, allowed everything to spin, and then when you stopped spinning the motor, it disengaged this, went back in, locked it all up. So I cut all that mechanism off and I 3D printed this bit that just went down over the end, glued on, and went on the end of the plunger. So that was my plan, to hook it all together. So what I originally did is I had this thing on the bench and I was just trying to measure. I'd have the thing out so far. I had this cool little non-metallic ruler here. It's just plastic, and I was measuring, overall travel that I thought I could get out of it. And it felt like it had decent power. It did 20 millimeters a stroke. So I work in metric. It's just a lot easier to do division and break things up, and machining nowadays is all pretty much in metric. So yeah, working in metric. And so I figured out 20 millimeters a stroke. So like I said, I printed this head up. This was from just this whole background piece from the get-go was just the first go. I started sketching up here, basically. Show you guys a little better angle. I had to do the math though, so I figured I had to do a 20 millimeter crank, so that's 10 millimeters a stroke. The rod length of 40 was just a rough guess. And this is all my head measurements here. And then this is just rough dimensions of this. So this gave me the dimensions here for the plate, which was pretty much from center. This had this cool little pin. There's a match on the other side to index it. So all my measurements are taken out the center line of that and this face here. So that compared my strokes. So that's where I got all that. So from the center of here, I had 91 the little metric units out to the center of my crank. So that's where that gave me that dimension. I measured in the little micro switch that I was using my timing device, and that gave me, I had to kind of math all that out down here. It's kind of hard to see, and everything the program I'm using to cut this in the laser light burn is all, you have to know where you're drawing stuff off, like the decimal system. So you do everything off, and my bed's 400. Anyways, I'm digressing. You're doing a lot of math, let's just put it that way. So I figured out this whole back plate as a test with the 20 millimeter stroke, and I put it together and went to run it, and it didn't really run. But here, I'll show you guys here. So if I hook up my power supply, and this is just a LiPo battery. This is a watt meter, just to show what kind of power we're pulling, and we'll get to that in a minute. And then to protect me from general purposes, this is out of the RC world, but this is a half amp fast. They call this a smoke stopper, but I I use it for general purposes. It's just an inline fuse, a 1/2 amp, so it protects me from, you know, having a little mini bomb in my face or destroying equipment. So anyways, make sure my timing device is not locked up. Plug this bad boy in. So if I have this out here, something like that, let's get this out. Yeah, so that travel clean. Oh, that was a serendipitous. I didn't even, oh, see, as soon as I click the little thing, it pulls it in. So out here like this, it seems to really, and just to show you guys, I lost my measuring device here. Oh, where'd my good one go? Did you guys see where I did that? All right, hit it back here. You guys already knew what I did with it. Horrible mess right now. I was trying to film all this. So like we'll get this out 22, because remember, right, it's 2 millimeters difference. Yeah, 2 millimeters on the back side between the head clearance. So we'll get at least 22 out. And if I run my switch, it pulls this in no problem. So anyways, that was the first crank I built. 20. If you guys are actually looking, this is from the center line of this and nowhere close to 20 millimeters. So this is actually 20 millimeters. Well, piston draw length. So the radius, half that would be 10. So this is 10 millimeters from the center here to the center of my 8 millimeter crank, just to give you guys scale. So, in this case you don't believe me, there we go. Frame a little better. Now, so anyways, I designed it all up, built it up like that, and I didn't know where my timing would need to be, so I built really long slots, if you could see in the back plate here. And I figured I kind of did them all kind of just from the center line one way to the other way. So I figured I could always change rotation if my timing was, estimations was that far off, and they were. Now all this is based off steam engines. Typically steam engines, if you're coming around here, I'm going to unplug this so we don't have it back in my, just I don't want this slamming in and just shock loading everything. That's what I'm saying, there's 2 millimeters clearance to bottom out on this. So I didn't want, so here is, because this is a pull system, we're not repelling. Do you notice every time we energize this, the magnetic field, that was, I guess I should cover that. There's a coil in here, and inside this coil, the solenoid creates magnetic field. This is not magnetic, and it can't pick up, you know, it's not, there's no magneticness to this, the magnetism. But if you put something like this part way in, this is, and hit it, you can see it's, see how it kind of, it's all too heavy, but anyways, it pulls it out of your hand. So it's just takes something ferrous, something that could be affected by magnetism. It can't be aluminum or whatever, like it won't affect the aluminum cranky piece here. We're not here to cover magnetism, so that's why there's no props or anything on that. I'm losing my washers. I don't want to go lose my washers. Yeah, I guess we'll find it when we got to go put it back together here in a second. So it pulls in on the crank. So versus all the measurements, I'm digressing, but all the measurements aren't from top dead center, they're from bottom to center. But in the steam world, you typically fire at top dead center or just before top dead center, because you're trying to cushion the parts as the early emission of steam kind of cushions the parts a little bit. And that's Kenneth Appleton. Check him out on YouTube. He's awesome for this old steamy stuff. But the early emission of steam helps to buffer the impact of parts. So that's what I was kind of thinking. I was thinking, oh, reverse steam engine, I'm just going to be pulling versus pushing. So if anything, I want early emission steam. So back to the original quiz at the beginning, this was designed to rotate this way. This had a really small nubular. It's actually, that's pretty scaled to what it was off of here, because I was trying to sketch it as well as I could. You know, high school drafting class, you know, I took high school drafting class when you had to do paper. It's kind of weird. And boards with these really weird elbow arms that they looked weird, but they're actually really functional if you got one that wasn't hung on by other students. But anyways, digressing again, how many times take a shot? How many times will Brad digress? But we found our washer, look at that. So because of the pull system, I figured it would come over top dead center, or bottom dead center, excuse me, and then pull, and then want to come in. Well, first off, I had too much drag going on. This was just hanging in the wind, so that didn't work with my original idea. So I redesigned the foot piece here to have this plate and go with a crosshead design like in Steam, so it rides on this plate. And just FYI, if you guys do this stuff, it's this, I keep getting on my fingers, is silicone. Silicone's the only thing I could find, pure silicone, that won't eat the acrylic or any of the plastics up. It still offer something as lube. So anyways, I didn't have enough. I had to change that, so I ended up adding this crosshead. Had to change you know, the end of it so it had as much support as possible, and the front of it was forward enough, because I already built this plate and cut everything onto it, so I had to move the front of the crosshead out. You know, things being different, I could have just moved this plate back here, but anyways, working with what I already built, I moved the front of the crosshead out. Had to redo my math because the center distance here was already set at 91 millimeters between the center of the crank and the center of this button. So I had to redo my math. So this was the original rod that with this crank. So we ditched all that, and then we came up with this. And now we're going to go apart. You guys have probably oh, you guys just took a face plant. Part you guys have been waiting here for a good minute. I don't know if you could hear it, but there's a pretty good monsoon going on outside. Dog's staring at me like something's wrong. And that's half the reason why we're filming this video, because I want him to think this is no big deal. So anyways, I'm gonna get my pen hooked up on here, and then this is just all 3D printed and laser cut acrylic. It is oh yeah, I got a laser, you guys. I think I didn't tell you that, but yeah, it's just a little diode laser, 10 watt. It's my little blue lightsaber. I'm pretty stoked on it. But anyways, so the minimum distance, because it didn't have enough I recut the crosshead, and because I wasn't really getting any usable power out that far, I shortened the throw down to the minimum distance that I could clear with this 3mm diameter bolt that I was using to connect my rod to my crank, and my 8mm pin that was 5.5 millimeters, because 4 plus 1.5 is half of this, plus half of this is 5.5, so it ended up with a throw of 11 millimeters. So I had to do my math, create the new crank. Just get this the right amount of loose, and this motor's not meant to run for a long time. That's why you just adjust these things, and that's why you guys don't need to get, that's kind of the whole point of this whole video, is don't get carried away, be ready to make adjustments. Oh yeah, my original plan was just acrylic and a bunch of lube and not use a bearing. No, I had to retrofit. That's a old worn out repurposed skateboard bearing pulled out of some scooter or something. But anyway, so let's give this a run. If I hook this up, and you guys ready? Which way did you guys think it was gonna run, huh? Is it gonna run with backwards, which would start, see how it's gonna close the switch off the lobe of the crank? Is it gonna run backwards with early emission? Or is it gonna run counterclockwise? Well, I kind of give it away right there. Backwards, that'd be reverse. Clockwise this way. So let's just give it a spin. Oh, look at that. Look how cool that is. Oh. What did I just change? Let me reset things. What just happened? There she goes. I don't know if I popped my fuse or what, but you can see she's quite a runner. There's no trick motor in the back, it's just the flywheel. And she'll pull down pretty low, but it's just a you gotta adjust the center line of this because just off that pin and a zip tie, because I didn't want to get crazy again with engineering again. That's the whole point of this, people. Learn to make adjustments, learn to play with stuff. I might do something with this in the future. One thing that would really improve is, as this crank went around, if I added, next time I get on a computer and get Warren to work with this thing, I'm going to add some more meat to the back side of this, so as it rotates around, it's hitting that switch and flipping it open. Well, right now there's not a long enough, it's coming on, the timing's good for it to start, but the duration that the power is on is not long enough. It's long enough for the motor to run, obviously, but I believe I get more power if on the back side of this crank, if I increase, and I've been trying to cheat it with the way I've bent the back of this thing out so it follows that the top of this longer. That's why there's that undercut bend. So once it hits, it kind of just stays on it longer. That's my way I'm cheating duration here. See that. Back curve of it. But if I added more meat to this side, then I could have got away probably with the original micro switch and not had a problem. But again, I'm just experimenting. And I was originally doing this all alligator leads, and once I got it done, I went, oh, okay, let's make this into a nice little debt stopper. So I was going to obviously add my favorite XT60 to everything, and I just laser cut this piece up next to another project that set on top, held the wire, bent the wire so it stays out of the way. Just so much fun to play with. And yeah, now we got a little neat little desktopper. So it'll probably, I don't know, probably get repurposed into something else, but for right now this video has gone on long enough. I hope you guys are kind of inspired to build your own little something like this. No, these fires will not be available because I accidentally deleted the back plate. But this is easy enough for you guys to build on your own. So just go out and build one and play around and have fun and yeah, enjoy yourselves. And hey guys, Adventure Brad out.